Hello there. Let's do the first video in our CompTIA A+ Core 1 series. Now the first topic's going to seem a bit weird, but we're going to do the troubleshooting methodology first. Now I know it seems a bit strange that we're going to look at troubleshooting now, yet we haven't covered anything like CPUs, motherboards, networking or anything like that. But here's the thing. If we go through the troubleshooting methodology, get that framework in your mind, and then when we start looking at things like how do CPUs work, what's the motherboard doing, how does networking function, while you're learning how these things work, you can also be thinking about, okay, so this happens and this happens, so if something goes wrong, that's going to cause an issue going forward. So it helps a lot to understand the troubleshooting methodology while you're learning how technology works. Because obviously in the workplace, you're not just going to be asked, oh, how does this work? You're going to be told, hey, fix this thing. And it's not just because you're starting out junior in IT. I promise you this whole, hey, fix this thing, exists throughout your entire IT career. It's just the thing gets more complicated as you go along. So let's have a look at CompTIA's general troubleshooting methodology. Now in the CompTIA course material, it's shown as a list. So let's go through it now, and then I'm going to show you how this list is a little bit more dynamic and flexible. So first you've got identify the problem. Now, getting a bit ahead of myself here, I'm probably going to repeat this a few times, but you don't always know what the problem is. You know something's wrong, and you've probably got symptoms at the very least. But what's causing those symptoms? That's your problem. So we're going to talk a lot about how to figure that out now. But once you've got an idea about what the problem might be, start establishing theories of probable cause. What created this problem, what led to it, so that you can try and rectify it. And then, test your theory to determine if your theory is correct. And then establish a plan of action to resolve the problem and implement your solution. Once you've implemented your solution, verify full functionality, and if you can, implement a preventative measure. And then finally, document your troubleshooting, the lessons learned, the actions, the outcomes, etc. Basically, record the stuff. So let's work through that, but in a bit more of a flexible manner. So you're starting out with identifying the problem. You'll have symptoms, you'll have error messages, you'll have information from the users, hopefully. And that gives you information that you can use to start creating a theory of probable cause. Now keep emphasizing the word here, probable. There can be many possibilities that could have caused an issue on the machine. Like let's say, for instance, lightning might have struck the building and fried the computer. But if there's been no thunderstorms recently, that is suddenly a lot less likely. So you've already eliminated a possibility without having to go through an extraneous testing process. Then, as we said, you test your theory. Now, one of the problems I have with showing it as a list, like CompTIA wants me to do it, is it takes away from the fact that, yes, you can go back if you need to. So if you test the theory, turns out your first idea wasn't it. Go back, try your next idea. But when you do go back, do me one massive favor, and anything you changed while testing your previous theory, undo that. You don't want to be on your third or your fourth idea, and it works, and then you're not quite sure, was it the last thing you did, or was it a combination of things? If you believe it might be a combination of things, you want to test that systematically so that you're making the bare minimum number of changes necessary. If you're changing stuff that you don't need to fix a problem, you can end up creating conditions for another problem further down the line. Now, there is also the possibility that this might be beyond your capabilities, so don't feel bad if you need to escalate the problem to a higher level with people that are more experienced, more knowledgeable, and ultimately it's their job responsibility. But if you do escalate to somebody else, follow up. You are the first point of contact for the user, and probably their most reliable way to find out how the problem's going and what the solutions are and stuff like that. Now, assuming you test your theory and it proves, hey, this is the problem, establish your plan and implement it straight away. This might seem a little bit weird, but at A+ level, you'll often be able to test, establish your plan, and implement the solution often in one quick go. But for larger problems, especially with things like networking and servers, the issue might not be that it's not working, it might just not be working properly or at full capacity. So you need to create a plan and implement the solution possibly after hours so that you don't cause an impact for the people that can still carry on working. And then verify full functionality of the system. And when we say verify full functionality, one of the best bits of advice I can give you is test it like a user would use it. And if you can, implement a preventative measure and make sure that doesn't cause any issues with anything else. The last thing you want is to be called back to another problem. And then document it, please, I beg of you. So we just looked at this troubleshooting methodology in two ways, but I like this method that I show here because it shows you that this method is flexible and dynamic. You can go back and treat it as just that, a methodology, a guideline, a framework to get through troubleshooting. I was once told, and I love the saying, that troubleshooting is a mixture of science and art. Once you know what's wrong, the science comes in as, okay, X, Y, and Z is wrong, do A, B, and C to fix it. But the art comes in with practice. You get better at troubleshooting the more you do it. The thing is, though, until you've got the years of experience behind you, you haven't got that practice in yet. And this methodology helps you by giving you a direction to go with when it comes to troubleshooting, instead of just diving in headfirst and changing stuff till something hopefully works. Now, let's talk about a couple of the more interesting steps in greater detail, like identifying the problem. So, where can you get information about what the problem is? Well, make a note of any error messages you see on the screen. Error messages can be amazingly useful, especially when they give you codes and stuff like that. Now, sometimes the codes might be very generic, so you might need to stick that in a search term with some context, such as the operating system or the software that might be giving you this error message, or any conditions that are pertinent at the time the error message pops up. But hopefully you're lucky and you get a decent error message. Also, look at how the system is behaving. Are you noticing any weird abnormalities and stuff like that? You'd be amazed by just looking at how a machine operates, what it's up to and stuff like that. You can figure out quite a few things. A very common bit of advice as well is to go and check on system logs. Now, I'm not going to go too deep into the logs here. We're going to talk more about logs with Windows and Linux later on in another video. So, come back for that. But my personal favorite place to get insight is to talk to the users. Consult with them, speak to them. You'd be amazed how useful and helpful the user's insights can be. Ask them to explain the problem, and if they can, to demonstrate the problem, because maybe it's a particular series of actions or combination of things that is causing the issue. And the user's the one that notices it. The user's the one that reports it to us. And let's be honest, we know, well, I know, and you will soon come to know, how computers work, how things behave, why they work the way they do. But the user doesn't understand the technicalities that you and I do. But the user uses that machine and those systems at the workplace all the time. So they're used to how it acts and behaves normally. And they need to try and explain to us what the abnormal behavior is, using the best words and techniques they can, which sadly isn't going to always be what you and I expect. So we need to first of all be patient with the users and make sure we're not confrontational. One of the best bits of advice I can give you for that is watch your wording. Don't say to the user, what did you do wrong? What did you do? What were you doing when the thing went wrong? Now the problem is I'm using a lot of accusatory language. I'm making it sound like it's the user's fault. And even if it is, you don't want to make it sound like that, because then they get confrontational and defensive. Rather say, what did the computer do? What did the computer do when you were doing something else? Make it sound like it's the machine rising up against them and trying to sabotage their life. And it'll help a lot there. Trust me, your users are not happy to see you. They only ever see us when there's a problem. So they're never going to be in a great mindset. So deal with that, be calm, be chilled, and watch your wording with them so that it doesn't feel like you're blaming them. And then, another very good piece of advice for identifying the problems can be check to see if anything has been changed recently. Hopefully you're at a workplace one day where they do good change management practices, and there will be records and documentation indicating what changes have been done. You can also just see if there was any recent troubleshooting and support that has been done on that system recently, and that will give you a clue of, hey, the last thing that changed is probably the cause of this, or might have been a change or two ago. But it's always a good idea. And if that type of information isn't available, ask the user, hey, has anybody worked on this machine recently or changed any settings recently? Not have you changed anything, but has anyone? And I would highly suggest that no matter what you do when you're identifying the problem, just do any pertinent backups that might be helpful. Back up the data, save stuff, you get the idea. There's been a number of times where people have said, oh, don't worry about backing up the data, I'm sure it'll be fine. Famous last words. Always do backups before you start troubleshooting if you need to. That way you know that no matter what happens, at least the data can be recovered. Now you might not need to do that all the time, but I definitely think that any time you want to do some troubleshooting that might lead, just ever so possibly, to data being lost, you want to do a backup. Rather be safe than sorry. Now let's talk about establishing your theories and testing them a little bit. Like I said earlier, consider your probable causes. This means you have to think of your possible causes and logically eliminate the improbable ones. Like I said just now, with the lightning strikes affecting the building, but if there hasn't been a thunderstorm recently, the chances are pretty low. Conduct a bit of research if you need to, and that means there's nothing wrong with doing things like just checking the system for any possible damage or any audible clues. Sometimes computers make noises that give us an idea. Try and recreate the problem if you need to. Check out any documentation and troubleshooting records. The vendor of the system might have some documentation you can check out. And seriously, nothing wrong with Googling stuff. Just do yourself a favor and make sure your search terms are helpful, not how do I fix a computer. Because you're going to get 1,001 solutions, and odds are the one that you need is going to be nowhere near the top of the search results. So that's why we said look at error messages and stuff like that. Using the symptoms, using the details when you're searching online or searching through documentation or forums will help a lot. And also, speak to your co-workers and the people that have been working in that role for a bit longer than you. They might have come across this problem already and they say, oh yeah, just do this thing and that thing and it fixes it. And that will give you a massive head start on figuring out what the problem is and coming up with a solution. And don't ever overlook basic things. You'd be amazed how easy it can be for a professional to overlook something. Like for instance, is it plugged in properly? Is it turned on? Stuff like that. I'm going to keep referencing these, hey, check the simple stuff. But a common mistake I've seen a lot of people make is you'll be talking to the user over the phone maybe, and you say, hey, can you just check if these cables are plugged in? The thing is, a user doesn't go and check like you and I would. They will look, they will see a cable that seems to be plugged in, but they won't actually go and make sure it's properly seated in the connector. It might be a little bit loose and not making proper contact, and that could be the cause of the issue. So question obvious things like that and don't assume anything. Especially if maybe one day you are in a more senior position and people are escalating problems to you. Don't assume the person before you has done all of those basic checks. A lot of people will think you're insulting them or treating them like idiots. As long as you don't make it too obvious, you can get away with it. And you're just saying you want to just double check things to make sure it's not a loose connection or something. Then, with the testing of your theories, try and avoid making the problem worse if you can foresee it. And test one thing at a time. Anytime you need to go back, undo your changes. And consider your organizational needs before you invest too much time and money in fixing an issue. Remember, we are there to support operations. IT and IT support are not self-serving things. We're there to keep the organization doing its thing. And troubleshooting and fixing a problem properly might take too much time or too much money and put that user or group of users out of action for too long. It is a bit frustrating sometimes when that happens, as you would love to get stuck into and fix the problem and know exactly how to resolve it in the future. But that might not be on the cards for you. And if you need to, escalate the issue, but always follow up when you escalate. Now, some advice when it comes to implementing a plan of action. Plans usually fall into the following categories: repairing the issue, replacing the faulty thing, or figuring out a workaround. And which plan you go for will usually be selected based on some of the following considerations, such as how long will it take you to implement the solution? So how long will it take me to repair the thing, replace it, or implement a workaround? What would the cost of my plan be financially? Is it going to potentially impact the system or anyone else and any other systems? Do I need authorization to implement my solution, especially if I'm spending the employer's money? And what's the user's operational needs? Can they do without the computer for a bit, or do they need it sorted out ASAP? In which case, something's got to give. And then the situation everyone gets nervous about: verification and documentation. So when you've implemented your solution and everything seems to be good, test the system fully. Use appropriate tools to test, and try and use the system like a user would use it. So for instance, if you are having an issue with printing, don't just go to the printer and print a test page from the printer. Go to a user's computer, open an application the user would usually use, and try and print a little test document that you quickly type up. That's testing the full system. Whereas if I go to the printer and push a button that prints out a test page, that just proves the printer mechanically is working, but it's not guaranteeing that I'm successfully getting a print job from the computer to the printer. So use it like a user would use it, and believe me, that will help you find faults that you didn't realize, or parts of the problem that only become apparent after you've implemented the first solution and got rid of the first set of symptoms. And when you can, implement a preventative measure, but only if possible. Don't beat yourself up to do it if it's not possible. If it's something that's going to reoccur and there's nothing you can do to stop it, that's life, I'm afraid. But if there's an opportunity to stop the issue reoccurring, well, why not? I'm sure some people are going to say why not in the comments, and those reasons can sometimes be quite justified. But that's an ethical, philosophical debate that I'm really not aiming to have right now. So let's move on to documentation, the thing that makes people nervous. So many organizations are actually encouraging documentation by the use of a ticketing system, where a fault gets logged, a ticket gets opened, and that ticket acts as a reference number that allows everybody to follow up on the issue, its solution, its status, and all of that good stuff. But organizations are growing beyond that and starting to turn the information that we fill into a ticketing system into a knowledge base. And this means that you can actually have a very cool resource at the workplace. Going and Googling a problem on the internet, fantastic, or any other search engine you might prefer using. But if I've got a resource at the workplace that outlines previous problems and solutions, I might want to go check there first, because there's a very strong chance this issue has happened before in this workplace, and the results from a search through the knowledge base are going to be far more relevant and likely to be the solution to my problem than some random article I find on the internet. Don't get me wrong, that random article might help a lot, especially if this is the first time this problem has ever shown up. But if you've got a knowledge base of previous troubleshooting, tests and solutions and all of that good stuff, go and consult it. It'll make your life a lot easier. And if you're allowed to, document at least for your own personal records. That way you can always consult back in the past. I will remember having fixed an issue a year ago, but I might not remember that one little step that I really need to know to get that solution to work. And believe you me, documentation is super valuable. A lot of people are nervous about it because they're worried it's going to affect their job security. And I'm going to tell you right here, right now, yes, there is the possibility you could be working somewhere and they decide to get rid of you and pay someone half as much to follow your existing documentation. Thing is, though, that person they're paying half as much to just read what you did and do what you did is not actually learning troubleshooting. They're just learning how to follow instructions. And when a new problem pops up, they don't know how to figure out a solution. You do. And if they get rid of you because of that, in fact, they've actually done you a favor. Because that kind of short-sighted management and leadership decisions are going to just manifest and magnify throughout the organization. A healthy workplace to work at will actually recognize that documentation and contributing to a shared knowledge base is teamwork, and it makes everyone's life easier. So don't be afraid to document your troubleshooting. You're helping yourself out, you're helping your co-workers out, and vice versa. They'll be helping you out too with what they solve. So don't be afraid to document. It's going to be beneficial in the long term. At the very least, do it for your own benefits. But that was a nice overview of troubleshooting. As I said at the beginning of this video, it is a bit weird that we started troubleshooting before we started looking at how anything works. But now that you've got a bit of a troubleshooting mindset going, it's going to make looking at how computers work and how things interact with each other a lot more helpful. Because as you're learning, you're also going to be thinking about how this can help you troubleshoot and resolve issues when you're dealing with, like, for example, RAM or storage or networking or anything like that that appears in the CompTIA A+ Core 1 objectives. So thank you for watching. I really appreciate it. If you haven't subscribed, please do so, and hope to see you in the next video.